So till now we have seen what is breadth first search, what is depth first search, what is the difference between them, what is the difference between tree and graph. Okay, so we have seen what is the algorithm is, and we have seen what is the process. Okay, now we will see what is the implementation of breadth first search and what do we need in Java to implement BFS. Fine. So we will have a node. So what does node class contain? Node class will contain the value of the node, that is for example 200, and also it will contain a boolean variable. It will also contain a boolean variable, and also it will contain a boolean variable that will specify whether the node is visited or not. So a variable visited, okay, a boolean variable visited, that will specify whether the node is visited or not. So this node class will contain two things. Fine. Two things. Whenever you create a node, so we have two values in that node, that is a 200, that is my data of the node, and second one, whether the node is visited or not. Fine. The second thing we will have is our adjacency matrix. So what adjacency matrix will help us do is, adjacency matrix will help us know who are the neighbors, correct? So if this is my adjacency matrix 1 to 3, 1 to 3 for example, so in 2 to 3 I have a 1, so 3 to 2 also I will have a 1, and 1 and 1 I will have a 1. So I have a node with 1 and 1, and I have a node with 2, 3. Fine. Here, so this is the adjacency matrix. So who are the neighbors? 2 and 3 are neighbors to each other. Just take this example. So 1 to 0 here and 1 here. Okay, so who are the neighbors? 1 is neighbor with 2, and 2 is neighbor with 1 and 3 both, and 3 is neighbor with only 2. So this is my example. Okay, so for the adjacency matrix, that is the 2D array, whichever we have a 1 and a 1 in a row and column, then those two are nothing but our neighbors. Fine. Next we have a node list. This will be an array containing the nodes. And remember, each node will contain a data and a visited value. The reason to have a node list is each node now can be represented using an index. Okay, since now this is an array containing the nodes, so each node now will be represented using an index. So if it is a node 0, it will be representing using index 0. If this is the first node that I insert, so it will be inserted where? In the node list, in the first index. So 50 can be accessed with the index of 0. If the next I insert 10, so 10 can be accessed by the index 1. If I insert 200 after that, so 200 will be accessed with the index 0. Fine. So this is the reason we are using a node list. Next we will have a BFS method, obviously. Okay, that is a breadth first search. We will have one more method to give us the unvisited node. Fine. This method will return me which nodes in the neighborhood is unvisited. So that method will use the adjacency matrix. And where this adjacency matrix will be stored is, we have two methods. One to add the nodes, and the second to add the edges. Fine. Two methods, add node and add edges. So add node will add the nodes, that is these two values, that is the data and the boolean visited, and the add edges will give us the neighbors. That 20 neighbor is 200 neighbor is 20 and 50, correct? So add edges will contain the adjacency matrix. This will contain the adjacency matrix. Fine. Because due to the edges we know who are the neighbors, and adjacency matrix keep tracks of the neighbors, correct? So with these all things will be there in our program. So we'll create a class node. Fine. We'll have a main class. We will also have a graph class will contain these methods, that is BFS, unvisited node, some other methods that we will use, and these are the important aspects of that graph class, correct? The structure of that graph class. So now we will start coding. So let's begin and create our node. So in our node class in Java, what we have two things, in data, and the next one is boolean. You know what we have. So we have a visited. Okay, this will keep track whether the node is visited or not. Fine. So we do not need an extra array. Okay, so node in data, this will be my constructor, and whenever a new node is created, this dot data will become data. Fine. And the next is boolean visited, that is visited will be false. So whenever a node is created, it will not be visited, it will be false. We are now creating the node, so we are creating the graph. So how do we create a graph? We create a graph using two things, that is the variables in my graph class and add node method and add edge method. Okay, so a graph consists of nodes and edges. So for the first, what we have to do is we have to add those two methods. Fine, add node and add edges. After these two methods are added, after that we can do BFS. Okay, so first we have to create our graph. So now I am creating my graph. Okay, so for that, let me have some variables. Private node, this is a node list array. Okay, so I told you we will have a node list array, so this is a node list array. Next we will have private integer. What is this? Can you guess using seeing the two subscripts? So this is adjacency matrix. This is nothing but adjacency matrix, correct? Next we will see a new number, private int number node. Okay, this will just keep track of the size. Fine, this is size, number of nodes that we have. Then we have private and a q class q. So this, what is this q class? Q class is nothing but q, which I have implemented beforehand. Okay, this is nothing but q. This contains our dq, nq functions, peak function, size function, is empty, is full functions. These functions are present in my q class. Okay, you have to implement this by your own, because before watching this you have already watched q. Fine, so you need to implement it. Let's go ahead. So graph, this is a constructor, and here I will pass the size. Here I will pass the size. Fine. Next we will have a int max nodes. Fine, equals to size, equals to size. So maximum number of nodes that we will have. Fine, so node list will now be initialized, equals to new node, and the max size the node list will have is max size, max nodes. Fine. Next we will have our adjacency matrix, and it will be initialized. So new int and two brackets. Here we will have max nodes, that is the size, max nodes, and here also we will have max nodes, that is the size. Fine. After that, what we will have? We will have number of nodes, which is currently 0, because nothing is added currently, nothing is added till now. Then we have a q, which will now initialize. Q equals to new q class, and here also max node. Okay, the size of the q will be equal to the max node. Fine, done. The part is done. Now I have the variables that I need to create my graph. Fine, now I need the methods for that. Okay, variables are done. Now I need methods. So the first method that we will create is add node. Fine, int element, that is the element that I will pass from the main class, and here node list. In the node list I will create. Fine, and here is number node. I have explained you this. Number node plus that the size will also increase, equals to new node element. Okay, so a new node will be created with the data equals to element. Fine, boolean equals to false, so it will go here, boolean will become false, data will become data, whatever we pass here. Okay, and it will be added to the new node list array, and the size of the node list will increase using this post increment. The next thing that we are going to use now after add is, what we will use after add? After that we will use add edge. Okay, so add edge. So we have added the nodes, we have to add now the edges. So we will start and end. See, these two are the variables, start and end. So what is start and end? Where the edge start and where the edge end. For example, in this array, edge starts for example, this is not any directional edge, so 200, and it ends at 20. So we have to add this edge between these two. Fine, so we will pass this from the main method. So adjacency matrix start end. Fine, this my index is equals to 1. So if there is an edge between these two indexes, we will insert a 1. Okay, and it is not enough to just to add from start to end. We have to also do from end to start, because this is bidirectional. Fine, done. There is no direction shown, so 1 to 2 is also an edge and 2 to 1 is also an edge. Therefore we have to add it to the both one. Fine, one more we can use is the print node. We can use one more function, that is nothing but a print node function, if I want to print my array, so my graph. So void print node, and simply I will pass the index of the node that I want to print, and system.out.println, and this node will be present in my node list array. Okay, and I will pass the index here dot data, and I only want data from it, not the visited boolean value. Fine, so this is print node. Done. This much is done. Fine. Now what I have done is I have created add node method, I have created add edge method. So my graph can be created now. Okay, using these variables and these methods, my graph can be created now. Now I'll create my graph, and after creating the graph, what we will do is we will implement our BFS function. We will implement our BFS function. So in the main method, as you can see, I have written some code. So this code is nothing but to create my graph and my edges. Okay, the same graph that we have seen before. As you can see, graph G equals to new graph, and the size is 8 because we have 8 nodes in our example. Okay, 1 2 3 4 5 6 7 and 8, and these values are added, and the edges are added. Okay, so you do not have to add 0 1 and 1 0 again, because in our function what we have did is start to end and end to start both are 1. Start to end and end to start both are 1. So if 0 1 is an edge, so do not want to add 1 0, you do not need to add it, because we have taken care of that in our this function, add edge function. Fine. So our graph is now functionally fully created. After that, what we have to do is go to our graph class, and here we have to do some more functions. We have to create some more methods. What are these methods? First method is for BFS. Okay, and one more method, that is that method that will return me the unvisited nodes, which will return me unvisited nodes. Fine. So now what we will do, we will create a method that will return us unvisited node. Fine. So get adjacent unvisited node. Fine, unvisited node, and here int node will be passed. So what it will take, it will take the index. Now whatever I will work on, I will not work on the data, I will work on the index. Why? All my nodes are present in my node list array, so I can use index directly to access them. To get the data, I will use dot data. To get the boolean function, I will use dot visited. Correct? So now let's see. So for int j equals to 0, j less than the number of nodes that we have, that is the size, and j plus plus. Correct? After this, in this what we will see, if my adjacency matrix of node and j equal to 1. So if there is an edge between the index node that I have passed, that I am checking, and j, then equal to 1, and then if there is a node between, if there is an edge between them, and node list of j dot visited is equal to false. Fine, is equal to false. So what we are checking in this if condition is whether there is an edge between my index that I have passed and the j, that is 0. Okay, if there is an edge, means they are neighbors. If there is an edge, means they are neighbors. And also what I am checking, whether it is false or not, whether they are visited or not. Fine. If they are visited, then it should be true, but if they are not visited, then it should be false. And what we want non-visited. That is the unvisited node. Fine. If these two conditions are true, then I will return my j. That is my index of the node that is still unvisited. If this condition is false, I will simply return a -1. Fine. So this was my get adjacent unvisited node. Okay, so what it will do is, I have shown you in this example also, if I add 50, so what it will pass, node value as 0. It will pass node value as 0. So the node value will become 0, and it will check for j equals to 0 to 8. It will check for j equal to 0 to 8, who all are the neighbors of node 0. It will get that 210, that is node with the index value of 2 and node with the index value of 1 are neighbor of 50. Okay, it will show. Also it will show that both are unvisited. So first it will return me 10, and afterwards it will return me 200, because 1 will come first and 2 will come afterwards. Okay, so this is how it will work. I hope you are understanding it, how unvisited node will work. So what it will return me the index of the node which is unvisited yet. Okay, after that what we have to do is we have to implement our BFS function, our main function, that is BFS. So this is the last method that we are implementing. Okay, after that our code is over. So node list of 0. So first when I am at BFS, so the first node that I am considering, I am starting with, is the node which I have added the first time. So the first I have added 50, so I am considering that I will start from 50. My BFS will start from 50. You can start from any node, not an issue, but I am starting from 50. Okay, so I will make that true, that I have visited 50. I have made that true, means I have visited 50. Then I will print it. Okay, I will print it. I have shown you these things. So how BFS works, it is visited 50, it will print, it will add it into the queue, it will add it into the queue dot enqueue function, and I will add 0. What I am passing the index. I am passing the index because I have node list. Now I do not have to work with the data value. I can work with the index value, correct? So I am enqueuing a node with index 0. Then int node1 is a variable which you will know why I will use it. So while queue is not empty, so this also is a function of my queue class. Okay, if it is not empty, then we will go inside of it, and inside of it I will create another function of node2, and I will store queue.dq. Fine. So this all I have explained you. First we will enqueue it, then we will dequeue it. Okay, we have already printed it, so first we will enqueue it, we will then dequeue it. Fine. So a node is dequeued while my node 1 equal to get adjacent node, and I will pass here node 2. So what I am doing here is not equal to -1. So what I am doing here is I am getting the adjacent of node 2 and I'm storing that in node 1. I am getting the adjacent of node 2 which is yet unvisited. I am storing that in node 1. So for example, I am getting the adjacent of 50 which is yet unvisited. So it will return me a 10, and I am returning the index of this 10 in node 1. Correct? So I am storing the index of this unvisited node to node 1. Correct? After that, simply node list of node 1 will become .visited will become true, because now I have visited 10, so it will become true. Afterwards, what I have to do, you have to print it. You have to print node of node 1, and after that you have to enqueue it. Okay, this I have explained. I have to enqueue it. So enqueue this node, that is node 1. Fine. So what is happening here is nothing but, what do you do? 50. Now I am explaining you the steps again with the help of a code. Fine. So what we are doing here is, I have node is currently 0. That is the index of our node is currently 0. Then it is checking for its neighbors. So first one, it will return me a node with index 1, that is node 10, and it is unvisited. Fine. So what it will say, that I am here, so make it visited. Print it. We will print it. So 50 is printed, 10 is printed. Correct. It is made visited. After, in BFS, what we do is, we will go back to 50 and we will check whether there is another unvisited node or not. Yes, there is another unvisited node, that is 200 with the index 2. So this while loop, what it is doing is, it is checking all the unvisited node of my node 50. Correct. So so after that, it will simply return me the index of 200. In our example, it will make it visited as true. It will print it and it will enqueue it. Now after that, what will happen? Now it will go to 10, and it will see its unvisited node. That is 15, afterwards 30, then 5, and then whole process will start. Fine. All the BFS will be doing. Okay. So you know the difference between BFS and DFS, correct? So now what we will do, we will go to our main function. In our main function, I will simply call my BFS function. Okay, so before that, I am just writing visited nodes are, and I will call my BFS function g.bfs. Okay, and done. So I will run the program, and after running the program, you can see that how I will visit in the BFS, the same way I will get the answer. Okay, so as you can see here, first I will visit 50, then I will visit its neighbors 10 and 200, correct? Then I will visit 10, and then afterwards I will visit its neighbors, that is 15 and 30. Fine. Then I will visit 200, I will visit its neighbors, that is 20, correct? Then I will visit 15 and its neighbor, that is 5. Then I will visit 30 and its neighbor, that is 300. So you can see here who are the neighbors. I've explained you this in the previous video also, who are the neighbors. Okay, so 50 neighbors are 210, correct? So first it will print me 50, then it will print me 10, then it will print me 200. After that, on the queue, the uppermost element is 10, so in the 10 it will print me nothing but 15 and 30. Fine. Then the uppermost element is 200, it will print me 20, the neighbor of 200. Then the uppermost element is 15, so it will print me the neighbor of 15, that is 5 and 30. Okay, so 30 is already printed, so it will not be printing again. After 15, 30 will be the uppermost element, and at last it will print me 300. So this will be my answer. So this is actually my answer: 50, 10, 200, 15, 30, 25, and 300. 50, 10, 200, 15, 30, 25, and 300. Fine. So this was how the graph is implemented in Java. The graph is implemented in Java. Now what I can do is I can simply show you using debugging the whole process which is happening in the backend, which I've already explained you using the PPTs. I have already explained you this whole process. Fine. So let's see what is happening. So g.add, so it will go to the add node function, it will increment the number node and it will add it into my node list. Okay, as you can see here in my node list, it is simply adding data equals to 50 and visited equals to false. Okay, now see, it will add, see, data becomes 50 and visited becomes false. Fine. After that, it is added, number node now will be increased to 1, as it is increased to 1. In my node list at it, one second, yes, and in my node list at index 0, now I have a node with data equals to 50 and visited equals to false. Correct? So this is working. So after that, we will add these different type of nodes, so many nodes that we are adding, and you can see now, I will just stop afterwards. Yes, see, so we have 4 nodes, we have currently 5 nodes in it. Okay, so we have nodes till data value equals to 30 and visited equals to false. Okay, so we have done, only 2 nodes are remaining, that is 5 and 300. Okay, so these 2 nodes will be added now. See, it is added. So I have total 7 nodes left. Now the edges will be added. After the nodes, what will be added? Edges will be added. Fine. So as you can see in the node list, we have total 8 elements, 0 to 7, and 0 is nothing but data equals to 50, visited equals to false, and the last element is data equals to 300 and visited equals to false. Now this is only an array of containing nodes. Okay, there is no relation between this and the other elements. There is no relation between 50 and 10 right now. After adding the edges, the relation will be coming. Okay, 50 will be the neighbor of 10 and 50 will be a neighbor of 200. After adding the nodes, after adding the edges, it will happen. So let me add the edges. So here the edges are added. This all added. Now I am adding the edges. So this is, one second, here. So so now what is happening is the edges are added completely. So what now what is happening is the edges are added completely. Okay, now after that, see, in the adjacency matrix the edges are added. Okay, so edges are added for 1 to 1, 2 to 1. Okay, fine. So this is what I am adding from node 1 to 1. So my adjacency matrix is done completely. Afterwards, I will call BFS and I will go to BFS. So node 0 will become true. So what will become true? Node 0 will become true. Let's see. Node 0 data value 50 became true because I have visited it. Now print node, it will print 50. It will simply print 50. Okay, see, it printed 50. Afterwards, it will enqueue. Q will enqueue this one. Q will enqueue. So let's see. It is enqueuing once again. And here all the function in my queue class and incrementing the rear and done. Okay, while queue is not empty. So yes, queue is not empty. And we will move inside. We will move simply inside. So in the queue now, I have a simple array, a front, a rear, a capacity of 8, and a count of 1. A count of 1. Why just a count of 1? See, in the queue, I have an array, a capacity, and a count of 1. And at index 0, you cannot actually see it, but index 0, I have a 0. Okay. When I add another element, you will see it. Okay. The difference. So this is the whole process how it takes place, correct? So now it will check in the adjacency matrix who are the neighbors. It will return me j value as 1. So j value is 1, so it will return me a 1, correct? So 10 is returning right now. What is returning right now? 10 is returning right now, correct? So after 10 is returned, so it will add node of visited equals to 2. So let me just show you. As you can see here in my node list, if I go to the first element, and yes, data of 10 will become true because it is now visited. It will print it. See, it is printing it here. After that, what will happen? Simply, it will go back and it will enqueue it. It will go back and it will enqueue it. So it is now what? Enqueuing 10 with the index of 1. With the index of 1. So 1 will become 1. 0 will become 0 and 1 will become 1. Therefore, in the queue, you will not see the difference. You will not see the difference. Even if I try to show you, in the queue, you will not see the difference. So 1 is 1 and 0 is 0, correct? So 2 will now become 2, 3 will become 3 after that. Fine, you can see it. So after that, what will happen? The same process, adjacency matrix is running, and now j will be returning with a value of 2. J will returning with a value of 2, that is 200. So the node with 200, data value is 200, will become true. That is the visited will become true with the node of 200. Okay, let me show you. So node list with 2, data value of 200 will become visited equals to true. After that it will enqueue it. It will simply enqueue it. It will print it and it will simply enqueue it. So the process are same, enqueue, dequeue, print. Okay, the process are same. Since it is enqueuing it, once again just give it time, it will enqueue, it will enqueue. Yes, it enqueued. So go to this, go to queue, and here you can see in the array node 2 is also enqueued. The node 2 is also with the index 2 is also enqueued. Fine. So this is how the whole process is working. This is how the whole process is working of BFS. And at the end it will simply print. At the end it will simply print different values. Okay, fine. After 50, 10 and 200, the next value that is printed are the neighbors of 10. What is the neighbor of 10? That is 15 and 30. As you can see here, neighbor of 10 is 15 and 30. So after that the visited will become of 15 or of 30. I don't know who is that will become first. Okay, so either one of it will become. So let's see. So j equals to 4 will become. So let's see what is the value of that. Who is it, 15 or 30? Go to the node list, go to 4. 15 will become true. After 15 becomes true, it will print 15, it will enqueue it, and after that 30 will become true. Okay, so this is the whole process of this whole breadth first traversal. Fine, I hope you understood it. I have explained this in PPT also. If you want, you can see it again. And this is the Java implementation for it. I have created a node class for our node, visited boolean and the data. After that I have created a graph class. In this graph class we have add node and add edge to create a graph, print node to print the nodes, and here I have that method to get me the unvisited nodes, and here I have a BFS method. I have a simple BFS method. Okay, in this BFS what we are doing, first we are printing the node. Okay, we are making it true, we are printing it, we are enqueuing it. Okay, we will dequeue it, we will add its children, and we will do the same process again and again. Not the children's but the neighbors. We will add its neighbors which are unvisited. Okay, because this will return only unvisited neighbors, and we will do the same process again and again. So I hope you understood how the BFS will work. Okay, what you can do is you can change the nodes, you can change the edges. Okay, you can write this whole line on your own. Okay, create your own graph and do it. You will understand it very better how BFS will work. You will understand it better how BFS will work. So just try to do it. Okay, write this code on your own and try to get your own graph. Okay, just try to draw your own adjacency matrix on a paper and then add these graphs and add these edges. Okay, create your own graph, then call the BFS function and see what is the final output. Fine.